Thank you all for having me. Glad to be surrounded by friends old and new. Jim already showed this figure here before, right? But historically, the trend has been over the past few decades, right? A surge in federal funding and support for projects involving social network data and analysis. One thing that we haven't touched yet, right, is a more recent development within the federal funding landscape is the introduction of requirements for data management and sharing or DMS policies, right? So now it's pretty commonplace to have some sort of, when you're submitting a grant, some sort of plan for making at least some portion of your data readily available and shared. And this is in the interest of providing reproducible studies, right? And also just maximizing return on investment for federal agencies. In general, right, when you're dealing sort of with standard sampling and survey data, right, data sharing might be more straightforward. With network data, because they're relational, right, it adds extra concerns, right? Because all of a sudden, if I'm reporting my network, I'm not just giving information about myself, which I've consented to, right? I'm giving information about other people who may not be aware of the survey taking place, right? And then their information is also contained and being shared. And in a presentation, I believe the next presentation, we're going to go into a bit more detail that creates challenges for 4 categories of concepts that we've identified: security, accessibility, reproducibility, and adaptability of network data. To try and address these issues as they pertain specifically to network data, right, and making DMS policies more feasible with network data, we've been working on a suite of tools that we've called IDEANet, which stands for Integrating Data Exchange and Analysis for Networks. IDEANet aims to maximize returns to scientific investment by making access and use of network data simple and more equitable. And our vision for this is 2 main categories of tools. The first is a distributed data archive architecture that we have kind of an initial framework for, and our goal going into the future is trying to kind of spread the gospel of it, see if more institutions are willing to adopt our approach. And then more on the user end, we've developed a set of streamlined analysis tools. I will caution, in the many years I've presented on this now, our target audience for these analysis tools tend to be entry level, right? So early career scholars, right? This is the advanced year of networks and health. So some of these tools may be, unnecessary for you, but I will argue there are specific advantages to it that may still pique your interest. We will get to that shortly. Admittedly, I'm less involved on the data archive side, so if I overlook any important information, I think in the Q&A, some more involved folks can contribute, right? But our vision for a system for more securely and easily sharing network data begins with a streamlined data depositing system for data owners. So we've created a template form that anyone interested in donating or sharing their data would answer basic questions about their network, what sort of features it has, right? Kind of general metadata that would help other people looking for specific kinds of data be able to query that. And then it would also have categories for levels of restrictedness. Once that form is submitted, right, the data itself would be deposited in a distributed data archiving system. So our existing prototype is based off the Dataverse format. We're pretty happy with it, but we're open to exploring other possibilities with it. We've been beginning some talks with ICPSR as a possible place for hosting some of these data, at the very least, the more publicly available metadata surrounding some of these networks. So it would create a system where in some of these more public channels, you can get the very basic public version, and then once it piques your interest and you feel like, okay, I think this data set and its more specific, potentially restricted aspects might be very valuable to me, then you move on to the next step of getting full approval for the restricted data set. One of the things we've encountered in trying to develop this system is that different institutions and their IRBs and their legal teams have different, express different levels of willingness to make data collected at their institutions easy to access. And so our vision right now, like I said, at that sort of public free sharing level, make that sort of data available through something like ICPSR, right, that's easily accessible. But then this Dataverse framework for hosting networks within institutions that we've developed, and we've worked, tested it out at Duke, this is something we can then approach other universities and say, hey, this is a good system for hosting these kinds of data, right? And then they can set it up and host it on their own servers with their own security architecture and worry less about a more centralized system in that regard. But then, assuming that each university has its own repository in our format, well, how does data access of restricted data actually work? We've been working on an automated notary tool for data requesters. It builds off some existing work that some of the members of our team have also been involved in. But the idea would be that you can submit a request via this kind of standardized notary service, and it's standardized in a way that different IRBs would recognize it. And then once you submit the request, it can then go to the institution hosting the data, and it can be reviewed by the data stewards and their respective IRBs. And it basically would expedite the process of kind of negotiating access. Did I summarize that reasonably well? Okay, great. Phew, this is the part I was most worried about. As for the data analysis tool side, this is far more my wheelhouse. The core product here is the IDEANet R package. It's available on CRAN, the central repository, our archive network. There are developer versions accessible via our GitHub page if you want to implement new features, or historically, especially over the last couple of years, we've had members of this community test our package out on their data, and they discover little quirks that they want fixed, or this is something I work with the Network Canvas team, and just from them I've really learned they have such a polished piece of software, and it really comes from this active engagement with their community, and I'm trying to emulate that with this package as well. But sometimes we build features. We build in features faster than we do CRAN releases, right? So if there's something new that we built you're itching to try out, right, and we haven't put it on CRAN yet, just feel free to pull it off GitHub, test it out, let us know how it's working. The IDEANet package does a whole lot of things, right? It reads in a variety of different network data formats and file types. So if you're working with a collaborator and they give you a network stored as a PAIC file, right, it'll be able to read that in, or UCINet, binary UCINet files, but that's me getting too specific. So a variety of formats and file types. I should also say, not surprising with my involvement in the Network Canvas team, I would argue that IDEANet currently offers the most streamlined way to read in Network Canvas data, like an entire set of ego network surveys collected with the software. Really happy and proud that we have that in there. And once you've read in your data, we have a set of functions for processing the data, and just in general, just in a very streamlined way, generating all the basic measurements at both the node and the system level that you would want. And we offer this both for sociocentric and egocentric networks. And I think the egocentric network is actually a really nice feature of the IDEANet suite, because there are not as many ego network tools out there as there are for sociocentric. So that's something that I'm really proud of and really looking forward to getting feedback on and expanding. And then the last thing I'll say here, I could talk about this indefinitely, but another nice feature we have is that many of the core functions of our sociocentric workflow are contained in an interactive R-Shiny graphic user interface. So if coding is not your jam, right, fear not. You can do a lot of the basic network analysis just within the GUI, and it has options to just export the files with your node level measures, with your visualizations, so that you can use that downstream, maybe for modeling or for presentations, without having to worry about coding. One thing I will say about our measurement as well, Jim cautioned earlier, right, that increasingly having the know-how for coding is going away, right, as automated tools are proliferating. This is reducing the need for coding on your end, but you still need to be savvy as to decisions made about how things are calculated. Jim gave a couple examples of how iGraph, for instance, might treat edge weights, in a certain way that might mess up your measurement. One of the benefits of IDEANet is we have tried to prevent people from making some of those mistakes. So for instance, if iGraph has a function where it treats edge weights as distances rather than frequencies, right? You specify as your argument in our processing functions, the edges here are frequencies, and then whenever it's calculating, certain measures, it's making sure that it's treating the edges in the way that you desire. So we're holding, we're doing a bit more hand-holding from the R console than, might be before, but you still should be aware of the decisions we make. And one thing I will say is we have pretty good documentation in our package, and we're always looking to expand and improve on it, that as people adopt this and try it out, they should be able to understand why we've decided to measure things the way that we do. Before I get into the demo, I just want to say we released version 1.1 of the IDEANet package on CRAN literally last week. We've got some exciting new features. So one thing we've added is support for what we call multi-context data processing. If you have a data set that contains multiple sociocentric networks, our core processing function for sociocentric networks now is an option where we can specify, like, okay, this column in my data indicates which network this belongs to. So now you can process multiple networks in one go. I will say I generally prefer processing networks, one at a time, just because I think it errs on the side of caution. I would still, advise people to do that. But if you really want expediency, we do have that support. And everything I'm listing here has also been built into the Shiny app as well. So, so without the need for coding, you can quickly start playing around with multiple networks. Our CHAMP network, or CHAMP community detection algorithm, Jim's going to go into this in more detail on Friday. Yeah, on Friday. But that's a really neat algorithm for trying to identify sort of the optimal partitioning set for communities in your network. This is a screenshot of some of the results of CHAMP in an example. But we've implemented that in, and I think that's a really cool, unique feature. You're not going to find that in any other R package out there. And like I said, these improvements are included in the Shiny app, and we've just added quality improvements to other features that we've had in the 1.0 release as well. Any quick questions before I go into the demo? Okay, great. Where did I go? Entire screen. Okay, sigh of relief. There are other software. There exists other software that does what IDEANet does in terms of reading in a data set and just through a GUI measuring and visualizing. One thing I would say that that our tool offers that kind of departs, and I think is an advantage, especially for people newer to network analysis, is that we organize our different steps for processing and working with data across these different tabs along the top. And it allows people to explore their networks in a very procedural way that I think other applications don't organize their workflows. And I think, again, for people less experienced with working with networks, this is really helpful. It's the idea of, like, okay, how do I load the data? What decisions or what aspects of my data do I need to identify? Okay. We've gotten that part taken care of. Now let's talk about visualization. Let's talk about measurement. Let's talk about what we would need to set up for more advanced analysis. So here I'm going to just upload an example data set that we often use. Here I'm creating a version where I've basically created the same network but identified them as multiple instances of the same network. So we've got an edge list and a node list. We can see our data here ahead of time. And then in the process tab, I'm choosing the outgoing, the sender of the tie, the receiver of the tie. And if we had a weighted network, this is an unweighted network, but we can specify the weights. And we have choices about directionality of ties. This is an undirected network, like I said. If it's multi-relational, we have support for multi-relational networks. So if you've got a sociocentric network and it contains multiple types of ties, our function not only is going to be able to handle all those ties, it's also going to treat the network as a whole network, measure the network and node level attributes in that way, but also within each type of relation in your network. So it's going to do that all in one go. So here, I'm going to set relation type. This is just whether it's a male or female nominated friendship. This is a synthetic ad health data set. But just for illustration's sake, we're going to choose that. Type. And then I'm going to show off the support for multiple networks. We're going to choose the column that indicates what network we're dealing with and which network we'd like to process. And then here on the node side, we're going to choose this. And we also have this option for column with groups. This is for visualization purposes. Here I'm interested in coloring potentially nodes by racial identification, grade, and sex. Oh, what did I miss? Let's see. Gender, alter. I'm gonna, in the interest of simplicity, I'm just going to show a quick network here. So yeah, this is our visualization tab, and we have a variety of options. What I think is really convenient about this is that if you've ever worked with an iGraph and creating a visualization option, there's just a lot of things that you have to edit, and it's always a pain. I've been doing this for years. I forget the arguments. I really don't like doing it. Having a graph, having a GUI that you can quickly, make these edits, it's just really convenient. You don't have to type and figure out, what to say. We have the ability, once we're in the Visualize tab, we run a whole set of community detection algorithms on the network, already. So we can quickly color our nodes in our network, and it automatically generates a legend for different labels. If you have node level attributes that in the Process tab you set as groups, you can also color by those. We also have support for edge coloring. So if you have a multi-relational network, it'll color that as well, and it will generate the legend for you. And if you, in the instance that you don't fully like how the layout algorithm has set things, we do have the ability to make the network interactive. So we can kind of click and drag nodes to our liking. I personally like the interactivity of sometimes I think these algorithms put isolates too far away from the network. So just to make it a more compact visualization, I'll drag the nodes closer. Once we've kind of visualized our network, right, we can generate kind of overall summary metrics, right? So here we're seeing overall distributions in the network of key, commonly used node level centrality measures. We also have some system level summaries here. You can also quickly look at tables of your node level measurement and do some quick visualizations. And there's also an option to download a CSV file of your process node level measurements that you can then use in modeling. And then the neat thing, right, in this final tab is we have a few advanced analysis procedures that we offer within the Shiny app. MRQAP for predicting the likelihood of tie formation. Some of the positional analysis kind of role ways of measuring within networks that Jim mentioned. I think Jim's going to also go into that in more detail on Friday. But we have we have a very nice, efficient way of just running those procedures within the GUI. And then, as I mentioned, we've just added support for our CHAMP algorithm for optimal partitioning of communities in within the network. So that's the GUI in a nutshell. And then I need to plug this back in. Of course, I've thrown a lot at you all here, but of course, our work is never done. In the future, our plans are we want to expand the scope and operability of these tools even further. We're really keen on building, capitalizing on our existing support for ego networks, given that it seems to be one of the more valuable offerings of our tools. We still need to implement support for bipartite networks, but we have a clear vision for that. Building off of that, we also intend to build support for hypergraphs and multi-layer networks, which are we have multi-relational networks, but multi-layer networks is kind of the next step of that. We also want to build off our implementation of the CHAMP algorithm for better community and role detection. Some more support for downstream modeling, if not implementing those kinds of models into our tool itself, but at least processing our data so that, for instance, if you want to fit an ergom, we're going to generate the kind of data objects you need to just fit that ergom, right away. And then the last thing I'll say is that over the last year, we've really been testing these tools in educational contexts. So, like I said, our target audience for these tools was initially early career scholars, but we realized with how much we were simplifying things, undergraduates could be using this to learn. And so over the last year, we've tested using these as teaching tools in a few undergraduate classes. It's been pretty successful, and we recently submitted a pedagogy manuscript about it that just got an R&R at Teaching Sociology. So, I've really enjoyed being able to use it as a teaching tool, and I think to a more advanced audience like this, right? What would the value be? If you're teaching a course on social network analysis, I might suggest our tools as something that students can use to kind of engage with networks in a hands-on fashion. And with that, I'd like to thank you for your time. Our work to date has only been possible with support from the National Science Foundation. And special thanks to Jim, Dana, Peter Muka, who's not here, Gabe, and our various other collaborators. Yes, thank you. Yep.
I have a comment. I did use it in a class recently with intro to networks and work.
Yeah, glad to hear. Yeah, it's.
I'm a plug for it.
Yeah.
From the front lines.
Yeah, no, it is a lot of fun, and I think, yeah, with what I've found is that with working with undergraduates, including courses I've worked on with Craig in the past as well. It's really hard to gauge students' ability to code, right? Even when they have taken prerequisites that expose them to coding in R, I'm seeing some nods of agreement, right? Trying to refresh people's memory, it doesn't always work. So it's always nice to kind of assume you have to take a couple steps back. And I feel like what IDEANet offers from a coding standpoint of really simplifying some of these processes, it helps meet a lot of students where they are, and then you're spending. It's always hard to cram everything you want into a syllabus and a lesson plan, right? And I think the time saved by using IDEANet in the classroom is time you can spend on more substantive concepts rather than tech support and troubleshooting.
So this will allow you to use these tools accurately without losing guardrails. So that, and what's beautiful about it is you read in a data set, push a button, and then you get out a data set with every standard node level metric you want, most of the group level metrics, and other things. So it really is a nice way to sort of get up to speed on using the data set that you wouldn't otherwise have. And that was I see they're setting up for lunch now, so we have probably take a little while for them to set up. The usual plan for the lunch talks or the lunch discussions are that we get to lunch and have the discussion. I think we will do that as well today since they're already here, but so they're taking a little bit of a minute. So go ahead and get up, move around, take a break. We'll do lunch, and we'll plan on starting the discussion probably in about 15 minutes or so, and then we will have that. We'll talk while we